Hello everyone, back again. So it's been a while since I last did some streaming. I think some people noticed in the last few days I was uploading some of the previously final streams that I had done, and I uploaded those to YouTube with a view to kicking off the streaming again. This will be a little more unstructured. I'm more just dipping in and out of a programming language project that I've been continuing recently enough. So where I had been previously was I was documenting more or less the whole journey from start to finish of developing this programming language from scratch, writing it in Rust. It was aiming to be a pseudo bash script replacement, so with an emphasis on making a programming language that had the, shall we say, ergonomics of being able to run programs very easily like in bash scripts, but keeping some of the niceties that we're used to with other programming languages. So we're not dealing with the typical bash style ifs and whiles and things like that with the bash syntax, but looking at how that could look with a more friendly, or at least more familiar C style syntax. And in the last couple of weeks I've been going back into that a little and, shall we say, taking what had been done before. So in the previous stream, what I had been doing is, like I said, writing this thing from scratch, but I was also only doing development on that more or less during the scheduled streaming times that I had pre-allocated. And one thing that I skipped during that process was the fact that I wanted to have as much content in the stream as possible. So I was focusing very much on features and adding loads of features. Well, loads is maybe a hyperbole, but adding as many features as I could during the stream itself. But I then was foregoing the essential parts of actually writing a practical programming language, namely writing comprehensive tests, adding documentation, things like that. And so what I've been doing in the last couple of weeks is taking what I had done previously and basically starting a new project and importing the features piece by piece. And so we can see here, so I've been calling this language CLang with the idea that this seed will be the core of multiple other languages. So it's going to be mostly having a research focus. So this kind of core language isn't going to be a production ready language in and of itself. It's going to be more of a research basis, which can then be added to or taken from to try out different programming design ideas, and also potentially writing more production ready languages. Now, the idea is to have this course still be very well tested and maintained and things like that. So far, most of what I've done really is adding support for various value types. So we have, for example, support for booleans, integers. I've added proper error handling, so no more just returning strings to indicate errors. We have variable assignments, we've blocks, and basically the most recent thing that I've added now is functions. And so there are now function calls and function definitions, and I thought that what I was getting into at the moment was interesting enough in and of itself that it could be worth having a stream from here. So here's my kind of new process for the streaming. So we can see some of the features that I've added on here, and I'm basically going to be going through this feature list to develop this new language. So what are some of the features that have been so far? Well, there's been support for printing, comments, the basic types, including compound types, variable assignment and declaration, blocks, and this new feature, which is the most recent one, which is calling, so this is calling built-in functions, which I had already, but now I've added calling user-defined functions. And this is quite interesting in itself, because even though I've actually defined function calls before I've actually added any interesting operations to the language, so I haven't actually added things like being able to add two numbers, being able to add two strings, things like that. I don't have support for if statements, so recursion is a tricky idea at the moment, because I can't have a base condition when I'm doing recursion. So I've really stripped down the function call idea to its bare bones at the moment. But even then, I'll just open up, and this is kind of one of the nice things that I like about the newest version of the project, is that I'm, like I say, paying a bit more attention to defining tests in particular. So this collection of tests are what I'm calling basically standard output tests, even though standard out is a bit of a misnomer, because it also checks standard error and return codes in some of these extended tests. But if I take a look at one of these test files, so we can see this is functions.test denotes a test file. And actually I might open up the project here, and so to see more of the details about how this actually works, anyone is free to take a look at build.rs, which actually generates the test files. So it's about 300 lines, so it's not too complicated. Essentially what it'll do is each of these test files defines a number of test sections. So a test section comprises of these equal symbols. I think there's maybe 60 of them. Do we go to, no, we go to column 50. So there's 50 of these, and then a test definition is broken into, for a .test file, for a basic test, is broken into two sections. And what will happen is the test framework will output the first part into a file, will then run that as a program, will run that as a script, and then will check this. So this second section defines the expected output of running this as a script. And then after the test marker is the test name as well. So for example, this will generate a file called functions/a.sd, SD for script in the C language. And so this script will be passed. In fact, I can probably check where some of this has been output to. So yes, if I refresh the directory here, and this is the functions file, we can see that each of these files got generated. So there's an a.sd, a b.sd, and we have this basic closure test as well. And so if I take a look at the tests.rs that actually gets generated, we can see how these functions actually get called, which shouldn't be anything too surprising. It basically defines the test name. It runs that is, let's see, I would say the interpreter. Oh no, that's the file that, or that's the working directory that the script will get run in, or that the interpreter will get run in. This is the file that it will pass to the interpreter. It'll be the only argument to the interpreter. We'll have this source code will get written to this file, and then we will expect, so I'll go to, let's see, functions module. And so we will expect an exit code of 0, we'll expect the standard out to be this, and we'll expect the standard error to be that. And most of that is accomplished just using the, I believe it's the assert command Rust package. And so that gives a nice, in my opinion anyway, at least for my purposes, testing framework just for checking the essentials for the language. So for example, here are some of the initial tests for functions. So even though we don't have any complicated operations that we can actually do, we can at least test that calling a function works as expected. So if we define a function that prints hello world and then we call that function, we get the expected output. We can call a function with different parameters and those work as expected. So the bindings get created as expected. And actually, now that I think of it, there could be an interesting test here that I haven't made. So I'll create a new one in runtime errors, I would say, where if we define the same name twice in the argument list. So that might be something I'll add. Let's see. So just before I distract myself with that, in fact, I'll do that here. So param already in scope. Param duplicate param name. And so I'll explain these exit code bits later, though hopefully they're a little self-explanatory. But then the third test that I'm working on with functions, and something that might need a little more testing as well, especially when it gets to the point where I'm defining recursion, I think will be, or at least defining functions in functions, because at the moment, because there aren't many operations, it's kind of trickier to test this more comprehensively, I feel. But with a basic closure here, we can say that when we define a function and we overwrite a variable, it will close over the outside scope. So in this case, the outer scope is the global scope. And when we print before and after overwriting the global variable gets overwritten as we'd expect. Now, that is more or less it for the what's kind of testable at the moment with the functions. So just before I go into what I'm currently testing, I'll explain these X tests or extended tests, which are essentially the same idea. So we split the file into these blocks of tests, or these test blocks, I guess. And instead of being split into the source code and the expected output, this is split into 4 sections. So we have the expected exit code of the script when this is run. So for all of these runtime errors, we expect an exit code of 103. I believe 102 is a parse error and 101 is a lexing error. But those are likely subject to change. The reason I have exit code here, number one, makes it a little readable, but if I actually add more capabilities to these extended tests, this preamble section will probably be maybe YAML formatted, so that it'll give it a bit more flexibility. Then we'll have this script area, we'll have this standard out section, and then we'll have a standard error section. So most of these runtime error tests will output a error message to standard error. So for example here, if we try to call a string as a function, it'll say value is not a function, although I think that's going to be changing in this commit. So what I'm working on at the moment is, and this is just something I started thinking about yesterday, that I probably have enough capability in the language at the moment to start adding in stack traces. So again, even though I don't have any sophisticated or even basic operations such as addition and subtraction, the function, so to speak, sophistication of the function call system is such that I can start taking a look at defining stack traces and things like that. So what I have so far is kind of a basic version. So again, this is where I've gotten myself to with the formatting. So the formatting is a little skewed at the moment. So at the moment, it's giving me the file that was run, and then it's giving me the stack trace, and then it's giving me the line number and column that the error was encountered in. And I'm getting all this, I'm getting the full path to the script rather than just the message on its own, or just the script relative to the directory that I'm working from. So I'm just going to play around at the moment with, whoops, I'm rusty here. So I'm going to be playing around with the formatting. Basically, I'm going to, so far this is my kind of error function, how I'm constructing or deconstructing at the moment errors. So when we get to a point where a runtime error is encountered, and I'll take a look at the errors file as well, or the error enum file, I guess. So we have a selection of errors which will be, I guess you could call them our root or our leaf errors. So these are the core errors that this is the thing that went wrong. So an example of this, we tried to redefine a variable that was, or tried to declare a variable that was already declared, or we tried to use a variable that wasn't defined, so on and so forth. Built-in function error is an interesting one. I'm not sure that I like that I've called it error, actually. I just noticed that now. But it will essentially just wrap so for built-in functions, they're ones that are defined in Rust rather than the language that I'm actually creating at the moment. So in order to convert a Rust error or a pseudo Rust error into an error of the language itself, we use this to wrap it. This is, like it says in the comment, a bit of a hacky way of adding line number information to errors in a generic way. So rather than each of these errors adding line number information almost in a custom way, adding 2 extra fields, this kind of wraps any error and adds that information. It's maybe not the nicest approach that I don't know, it just doesn't sit well with me at the moment, but it does what it needs to do in my opinion. So, and then we have all these basically error wrapping types, and the benefit of these is those will essentially, especially when it comes time to debugging, it can give me a pseudo stack trace from what's happening from a Rust point of view when an error occurs. So rather than just, and this is something I've experienced in Go as well, and I think others have as well, is that if you are just doing the simplest approach of, okay, I see an error has occurred, I'm just going to throw that up the stack, you quickly lose contextual information about what was actually going on when that error was occurred, or what, for example, I know Rust has a bit more sophistication in terms of being able to generate and capture stack traces, for example, but this is still a useful mechanism for being able to reverse engineer what was happening when your error occurred. And in particular, this is what I'm working with at the moment. So if, and I'll go into the eval section here. Please ignore all the all the temporary files that I have here. I have my own system for how I go back over, or how I back up files and reuse code in the past. I'm hoping to clear all this up once I get back to a certain critical mass of the language being implemented, but that's just what will be there for the time being. Anyway, we will have, let's see, expression call. And so when we perform a call, this is essentially where we are now, or where I am now in terms of implementing stack traces. When I am actually evaluating the statements defined in the function with the new bindings and closure and so on, if an error occurred during that evaluation, then I will add context as normal. So same as if I had an error with calling a built-in function, if I have an error with calling a user-defined function, then I will add that context using snafu to the current error that's being propagated. But what I'll actually add in this case is the name of the function that's being currently evaluated, if there is one. So this is an option string. So if the function doesn't have a name, then that won't get added. And then the call location, so where this function call is actually happening. This line and column number is coming from, it's something I capture. It's a little, I wouldn't say messy, but it's a little bit of a tricky thing that I've implemented using, with the help of some features of Lallerpop that I'm using for generating the parser. And essentially, whenever I have an expression, I'm capturing where that expression is in terms of line and column numbers. And so whenever I actually evaluate an expression, I have the line and column number of the current expression in the local scope of this eval expression function. So when I get to this point, calling a function is itself evaluating an expression. So if that fails, I will register the location of the current expression, which I'm saying is the call location. And so with all those different bits in place, I get back to this function that I use to actually render an evaluation error at the root of the program. So in the main.rs file, essentially what I'll do is, at the moment these are really only here for debugging information for myself, so later I might have a debug flag that I can use to make these useful, more or less. But at the moment I basically just strip those out because they're not really user facing. So essentially, if I encounter an error that wraps another error, then I will just grab the inner error and render that instead. And then these are intended to be all the wrapping errors. So bar this one, which is a special one that I'm handling at the moment, and I'll mention that in a second. And then all the other errors, which are our supposed root errors, these are all intended to, again, using Snafu, have their own display value defined. So we'll just format those, and those should automatically get their display string. And finally, here we have eval function. So this is the one where we do something a bit more sophisticated. So first of all, we render the inner error, same as we do with the regular wrapped errors, but we will also be adding stack trace information at this point. So for example, and actually what I can do is I can give an example of this being rendered in a slightly different way, because if so S is the, shall we say, root error that we've gotten so far. F is the name of the function that was being called, and the line number and column that it was being called from when the error was occurred. P is the path to the current script that's being defined. At the moment, there's only going to be one of these because I don't have imports defined, for example. And then the call location is we get that information here from the eval func as well. And so with those bits in place, and I save that update, we should be able to see some example of a stack trace. Now it's not yet in the format that I want, so we can see stack. So the script that was running, it'll say stack trace. This is the, so if we take a look at what file was this? So yeah, I'll take a look at stacktrace.xtest. And so this is eventually what I'd like to have. So it'll just say stack trace at the moment. Very similar to Python. In fact, I think I have, yeah, an example of what Python looks like when it encounters an error. So I've defined this G, F, and H in a bit of a random order, but it'll say, okay, here's a stack trace, or traceback as Python calls it. Here's where everything's happening, and then finally there's a type error. This is the root error that happened. One additional thing that I'm going to be adding is, I think it will actually be useful to have the column number when this happens as well. And in general, that won't be too useful, but this probably harks back to more my days with Java, and especially I think there was a certain time where I guess chaining method calls was kind of all the rage. And so you might have an expression such as F, G, H, J, something like that. And so, or you might have, like with a string builder, you might do 1, hello, 3, for example, and it will say, oh, concat failed on this line, and you're like, well, there are 3 concats in this line. Now, it's not the most difficult thing to debug. Even without the column information, you might even just split it onto multiple lines to make things easier. But just having the column information here seems like a somewhat easy way of making things a little easier, at least. So with that said and in mind, one thing that I want to do is I want to strip out this absolute directory information. So where are we? So first of all, I'll go to where the call to render eval error is, and we have the path. And so that's the full path to the script. And it looks like raw current relative script path. could have, so that's raw. So if I remove the rawness of it and I turn it into an actual path, then I can do that. Curl script path, and that should, so eval path, eval failed. Did I add that in this? Commit, I'm not sure. Let's see, eval failed. Yeah, so I added that there, so I can remove that, I think. Although I'm also taking the relative path in here. Might be useful to have it in being added to the context here. Yeah, let's try that instead. So we have curl script path, and 87. Yeah, so we'll just change the path, the variable that gets added. Now I might need to, oh no, that's all right. Yeah, and so we're a good chunk of the way there now, so it's actually properly adding that information. So I'm just thinking that, so now at the moment I'm just concatenating building up the string in a relatively naive way. So it's just concatenating on the different parts. What I can do is split it up into, so update this render eval error to be a bit more sophisticated and return both a vector of string, and again I could get more sophisticated with this, but a vector of string would be fine to define the actual stack trace, and then the final string for the error itself. So let's see. Actually, one thing that this also does is this will evaluate the display version of @lock or @location, which again adds the line and column number to another error. So this will both render that and the wrapped error. So that's something to take notice of as well. And so one thing to decide here as well is the direction of the stack. Not that it really matters too much, I think anyway, especially since it can be changed later easily enough. But let's see. And whether I want to add any metadata like third called, second called, first, and so on. But let's see. Do we want to just follow the Python approach and give the error at the bottom? I kind of feel like putting the error at the bottom makes sense, I think, when you have a REPL like this, so that's the last one that you see. I'm kind of thinking that I'd like to put it at the top. I think that's kind of what Go does as well. So I don't think this decision that's too important, especially for now, and especially since this language in and of itself, oh, I say that a lot, don't I? So this language is going to be more research based anyway, and so by the time it's being turned into a production language, if it's necessary, then this can be changed. So let's see. If I am doing it in that way, and what's the order here? So first calls second, which calls third, which has the error. And so we're going up the stack trace and up the stack, and this is the function that the error actually occurred in. So it makes sense for that to be at the top. Yeah, so if I want my now whether now this is the actual call to third. This is, so if I go up here and count down 10 lines, this is the line that the error actually occurred in. And so the stack trace is maybe more reliably described as this. Yeah, I think that probably makes more sense. And so how does that line up with the actual implementation of a call and the error that results. So when a function called fails, we capture the error and we add more context as the error is being propagated. So we'll add the function name and the call location. So for example, in this case, if the error gets thrown here while we're evaluating third, we're going to add this name and the location at which it was called, rather than saying that this happened in second. So as opposed to capturing the function that we're in when the call failed, we're capturing the function that failed and where that was called from. And I think that makes sense logically. So in order to get the rendering that I'm talking about down here, I think we just have to shift the function name and that should be all right. Yeah, I think that still makes sense. So, I mean, it's going to work either way, but it's just to figure out, should it work, or is it working against the logic of the system to do it that way? And I think it's all right. So just going back to render eval error. Eval error to stack trace. Yeah, and I won't give it I could give this return value its own type and be kind of clever about it, but I think that's all right. Since this function is only used in one place at the moment anyway, I don't think I need to be too careful about giving it a proper type here. Like I can just use a tuple. So let's see. Am I better off building up the stack trace in the function, or should I parameterize a part of it? I think because of the way it's being structured now, I'll need to parameterize it. And I might put the error at the end here. be able to just build it up using string formatting. How are we so far anyway? What's that looking like? So it's currently looking like I think that's almost what I want. Now, if I knew that there was always going to be a stack trace, don't love this, but just for seeing what it would look like. Cool. So we have this can't call int as a function, and path, where's path defined? Path is there, and then yeah, instead of f we're going curl func. Cool, so that actually looks like more or less exactly what I'm wanting. So we'll see, oh, this error occurred on line 10. So if we go down 10, we see, oh yeah, that happened in third. So we would have to go here. Might have to play around with at location there. Anyway, so we'll go 13 down, yeah, or sorry, so 10 is where it got called. Where did that get called? Well, that got called from line 6 in second. Yeah, that got called from the function first. Yeah, like it's funny. It's trying to figure out what the best way to represent this information is, but you know, the information's all kind of there, and regardless of how you piece these things together, you kind of come to the same conclusion. So I might be overthinking it really in terms of the sequencing and things like that. I just noticed there actually the GitHub section I have. Whoops. Yeah, the GitHub information box that I have there hasn't got the right information. Yeah, I'll change that later. So the current instance of the project is this. So we have Izanmoro seed is the current version anyway. And that's what I'm working on at the moment. So yeah, I think I'm just gonna go ahead with this rendering. Again, it's very easy to overcomplicate this stuff, even conceptually. So I'm going to go ahead and yeah, I think I will break this down into its parts. Debugging version there for the moment. Oops. Oh yeah. That's to be expected. So we have BT and root error. And so the way we'll render that is, and it should be ST for stack trace. Again, just trying to be consistent with the naming here. And I don't really want to output a full stack trace if the error is occurring in the root as well. So I might have a bit of smarts around that too, even though consistency is nice. But for that simple edge case, yeah, I think I'll leave the stack trace out if it's empty. So let's see. Okay, so we're getting places, yeah, and we don't want to have that there. And yeah, because the first item in the join isn't actually given the separation character, we have to add those extra spaces in manually. So what am I doing? So I get which yeah, I think I need to separate that out. So where are we at? Location error is in here. Oops. So I'm going to do something similar here. So that's our funk. Six. Yeah. So let's see. Oh, I've messed something up there. Oh yeah, yeah. I'm using apostrophes elsewhere, so I won't use backticks for marking code. I will have this be an option. Makes things a little more convoluted, but it gets me the formatting that I want, so I'll just go with it. So we're going to change how it's going to look. So if let, so let's try that. 278 expected function. Two 6.9 can't be formatted. Up my tmux setup like that. Can I want the editor and the git on the left. Can I do no? I have to. Okay. Now back to where I was. At least I don't have too many panes open in this one. So that doesn't implement display. That should never be the case anyway, but we'll double check. Let's see, so what have we got now? So we've got, yeah, I think that's actually what I want. I just need to update the text expectation to be what I want. Let's try that. So I've updated the message on functions as well. I should probably add that to a separate brand. So I should probably change that in a following commit. What have we done? Oh, did that? Whoops. I'd say that compiled before I changed branches back. I think and hope that's all it was. Yeah, I think that's it. And so I have an extra space being added in somewhere. I would say that's this. Okay, and so that seems to be the stack trace for the actual stack trace test done. I think the rest of the tests are just the rendering. For the regular errors. Duplicate param name is a new test. So I'll remove that for the moment, yeah. And then the parse errors. Oh, yeah, that one's for something else as well, actually. So I'll back that up. And let's see what happens here. Oh, that's all of them passing actually. Nice one. So 264, what have we got here? Yeah. So it's just clippy errors at this point. So 92, yeah, is empty. Mm, 93. And in terms of the just general readability of this whole section now, let's see. So to a stack trace, ideally I'd probably call that to stack trace and root error, but and I could also capture that with a type instead, so it could be a struct with a stack trace and would that make sense for the sake of it? Yeah, it might actually make things a little clearer. actually, can't I? And I'll add this in for consistency between the error cases. That is not found, so I'll have to. I'm probably missing some obvious converter function that someone else would be able to spot easily enough, but I'm just going to go with what I know. And then 88. Yeah, that's interesting. I wonder how that would work with a runtime error being returned from a built-in function, but I don't think I have an easy way of generating that kind of an error at the moment. So, because the only built-in function I have at the moment is print, and oh, I do have a function I can do that with, so let's give that a go. Trace. So if I call print with 2 arguments, so first we'll do no stack trace. And so that should be just line 1 and column 1 if I try to call 1 as a function. And that doesn't. Yeah, so let's see. So because built-in doesn't have the function name in it, we're getting that. So yeah, and we're not going to have a line number either, which is interesting. Print only takes one argument. Got 2. So let's see. So it should still say that it happens in third. And it should still give the line number. So let's see if I can add that back in somehow. So it's a built-in function error. Yeah, same way as I do with eval func failed. I'd say I should be able to do a eval. Where does func name come from? Okay, so I'll have to update some error stuff. I have a bit of inconsistency here with how I'm naming built-in func. I think I prefer it with lowercase. Go val func failed, that'll be func call, that'll be call. Update that in the value as well. I should be able to reuse that logic for built-in. Because it's the same types. and names. And that's main 257. Yeah, that doesn't exist anymore. So that's adding a stack trace element. Which makes sense, but whether I want to have it do it that way. Third. No, I think that would make it kind of inconsistent. Or this is another function call, as opposed to this where the error is actually occurring on that line. But then this isn't so clear. I guess when it's a built-in function, yeah, I'll have it work as if it's a root error. Oops. So that means I'll need to separate that out a bit. Let's see what we've got so far. Cool. Nice one. And so I will add those changes that I have so far. Not adding anything silly, hopefully. So add support for error stack traces, and that should be about it. So I'll push those changes. And okay, so what are the things here? Oh yeah, there was just a change to an error message. Yeah, and Python has a nice way of collecting all those different type errors. I think it makes sense to do it that way, but I'll leave it the way it is for the moment. So if I, for example, if I try to call an integer as a function, that's a type error, same as adding an integer and a string. So those are all type errors, which is a nice way of unifying them, but I haven't thought about how and whether to apply that here, so I'm going to leave it for the moment. And runtime errors, non-func. Can't call string as a function. And was there something else I had in my Scratch file? Yeah, I've done stack traces. I have a preliminary closure test, but I should probably add more when I can. Let's see. I think I can get rid of that. I have bools now. And what else? Yeah, ints are too big. I should add a test for that. Oh yes, there was another test I wanted to do, which was the duplicate argument names when defining a function. I have to remember to update the features document as well. I don't think I need to add stack traces in there. So now I wonder what level that will be. That'll still be a runtime error. I should re-update my find command so that it also finds things in the test directory. Oh no. Oh. Yeah, sometimes I don't know if I'm in insert mode in bash or if I'm after sending control and S to the terminal and it's just frozen. I would like to get some kind of a more modern terminal at some point. Or I'd really like to implement one, but not sure I quite have the time. So let's see. So, so there was no error there. That's very interesting and very bold. And so if I go print, let's see. Let's try that. I presume it'll print 2. In fact, I should make that fail. Ooh, I don't like that. Oh, what's going on there? That's very interesting. Okay, let's do a sneaky bit of just print lining. Oh, do I need to plug this in? Okay. Let's see. Let's try that. Okay. So we want dupe arg names. So we have a oops. We've val with source 1 and vals with source 2. Oh, did I just call print? Okay, I'm very, oh, yeah. Yeah. That was quite silly of me. And so it should probably result in a runtime error here when it's called, but not when it's actually declared. So yeah, A is already defined in the current scope. So runtime errors, dupe arg names 1.9. Would be kind of cool if I could show the location where the previous definition was. So let's see, I'll add that as a comment already. That might not actually be as complicated to do as I would imagine. Now, let me think. The reason, so let's stay on track here actually. Oh yeah, that's enough. Interesting, it's outputting a stack trace for that. So because it's at the point where a function call has occurred. So let's see, line 4, 1 in root 1.9 in F. A is already defined in the current scope. So what are the things that came to my head? Well, first of all, stay on track. Come on. So first of all, why can't we? So this error isn't getting captured when the function is defined, but it is captured when the function is called. So why can't we do a simple check to at the point of definition? So we just go through all the parameters and see, oh, if there's a duplicate name among them, then return an error at that point. And maybe that's possible, but something to note is that it's not as simple in this language anyway as just going through the argument list, because it could actually be, there could be deconstruction going on as well. But it should be possible to just walk that tree of variable name definite, because eventually each of those is going to boil down to some kind of variable name. So that's something to maybe add to the scratch list as well. So to do throw runtime errors, dupe arg names, throw error at point of definition rather than call point. So first of all, we'll add that just as a test on its own, because that's useful in its own right. Was there another runtime test that I wanted to add as well? Too many things coming to mind at the same time. Anyway. So there's the point of definition and now, yes. So adding the previous definition point. Breaking it up like that, but it makes it easier to display in that way. So eval bind, and the reason this should be, if I'm not misremembering, the reason this should be at least not too difficult to, where was it? Yeah, I'll bind. Not too difficult to implement is because I actually keep a hash set of the names in the current binding, whereas if we turn that into a hash map, I should be able to, I really need to share location, the location type with the other files. Oh, maybe it's in AST. Yeah. I'm a bit nervous when I use, so recently I've been having imports, what feel like import cycles in the project, because I'm not quite sure how to get some of the dependencies working otherwise with regards to, I can't even remember, either lifetimes or dependency orders. I'm not sure, but I feel like I have some import cycles in the project and they do make me uneasy, but that just is what it is. Now let's see, where are the other hash maps? Basically, I'll worry about it when it becomes a problem. Okay, so we have our names in binding now being locations, so 92. Oh. Previously already in binding and already in scope. That one could be trickier, maybe. I'm not sure. I'll have to check it out at some point. But yeah, so we have a location. I'll probably have to clone that. Yeah, that's all right. Oh, I put them on the wrong error type. Let's see, error previous. Let's try this. Oh, I need to get rid of that. I don't think I've any tests that are actually testing for already in binding yet, do I? Except this new one. But that's an already in scope error, not an already in binding error. Let's see what it would take to give that. Well, first of all, I'm going to stash the work in progress because at the moment I don't have tests for it, so I don't want to commit it just yet. Take to do that for already in scope. I would need to add that information to the scope stack. So the scope would have to map to values, and they'd also need to remember where they were defined. Which isn't an impossible task. It would make some of these functions and things less clean, I guess. But that needs to happen at some point anyway. They're going to be getting complicated at some point. I think this will be a nice enough feature to get. So let me see. So duplicating argument names, throw the error at the point of definition, save line number of previous definition, and integer too big are some of the things that I want to do next. Okay. So I would update declare to return a result instead. create. Oh, I guess I should create an error type. I mean, this is only ever going to have one kind of value, which is going to be a location. Such a minor thing, but okay, let's try that. And then we'll go bind declare. So oof, a lot of errors. So here we need to preserve the location that it was originally defined in. So when we're updating it with an assignment, Oh, it's been a while since I heard from the borrow checker. Cannot borrow as mutable because it's also borrowed as immutable. So I need to get that value and clone it, and then kinda hacky, but how's ever. So let's see. Do I definitely need to do all that? Immutable borrow. And then immutable borrow. Yeah, I think I do, because previously I did an is sum. So it meant that the lifespan of the unlocked scope being immutable was short, was just in the context of that value. I guess I'll do the all reliable of get it working first, and then once I have it working, then I can worry about making it pretty. Okay, that's cool. So if my eyes do not deceive me, runtime errors is already defined in the current scope at 1.6. Cool. I'm sure there are a few other. Yeah, already. So it's already defined in this current scope at, I would say, 1.1. And already in scope 3. Yeah, already defined in the current scope at 1.4. That's 4 because the function name itself is actually at the 4th position, and that would be at 1.1 as well. That's cool. So I'm going to change that that comment on the bind error to actually do that at the location. But I'll do that when I actually have tests to cover that case. Yeah, I don't think I'll create a new error type for covering that. And like I say, whoops. Yeah, I'll leave that test there. Cool, and that's a nice chunk of functionality added. And things that realistically I thought were going to take a lot more time and weren't really things that I had on the roadmap for the language so far, but turned out to be easy enough to add. So that's saving the actual full location of the previous definition and support for stack traces, which is pretty nice. And I am interested in the integer too big error. So let's see. Let's see what happens there. Yeah, positive overflow. I wonder, do I get the same if I... Yeah, and if I... What does Python say in that situation? Oops. Oops. Oh, I can't do Control A. Oh, because I have it on Vim mode. Oh. Just keeps going. Impressive. Yeah, I guess it defaults back to a, what's it called, big int or something internally when the integer gets too big. I'm probably not going to, well, no, I'm not going to add support for integers that big for the moment anyway. So what can I do instead? it'll basically just be, so yeah, parse int error. So I guess that'll be an error at parse time. So it's, oh no, it's in the lexer, so it'll be at lex time. Let's see. Oh, I actually want to take a bit of a break, but I also kind of want to see this done. I've been thinking about it for a while. So, and what line are we on? Line 99. This. I mean, it's from the logic here, the only realistic parse error that we could encounter here is that the integer is too big, because it should only consist of ASCII digits. So we should be able to rule out the possibility of, let's see, Rust parse. So that's string. It gets from. I'm not sure how that how that works. So from string error, the associated error which can be returned from parsing. don't really. Oh. Yeah, I don't really know how to read that. So. Because parse is so general. Oh no, that's to do with type inference though. Anyway, I've learned nothing. So let's see if we'll just do it like this. And otherwise return error. That's going to be okay. So that would be a max error int too big. Location would be start, I guess, and the raw int, I would guess I'd have to clone that, but well, not sure. Anywho, yeah, I need to remove that. Otherwise, error. Yeah, I really don't like how that section is looking. Oh, no, does not appeal. But oh well, 1, 2. Location for now. And we'll go to main 190. operation there at some point. Yeah, I will. Not sure how I remove that message. Used to be able to do that. Oh well. Don't want to pin it. Anyway, I'll focus on this. Not too much left in it anyway, I don't think. So right. Cool. So yeah, that'll be a, let me see, it should return a 101, I think, for parse errors. Let me see, render parse error. Oh no, I actually just have it returning 103 for all of them. That's alright. But in terms of the logic anyway, that's more or less it where I want it to be. However, the details, like how it's added into the Lexer, I think there's a lot of parts of it that just aren't as clean as I'd like, especially now that I'm rebuilding the project with that in mind. So I'm going to create a new branch and so I will address that later, and I'll update all the different bits to be a bit cleaner. When I have a bit more time to focus on that. So that's cool. So what will I be working on next? Oh yeah, so I have both defining and calling defined functions done. Yeah, I might as well do return values then, and then I'll continue on with operations like arithmetic and things like that. So I have that more or less done in a separate branch, but I just need to actually go back to it and tidy up a few bits and pieces like I have with the branch that I've just created there. So that's cool. Anyway, thanks to anyone who's checking this out, and looking forward to, like I say, getting this critical mass of features back into the core language again, and having a round 2 of the, I guess, scripting focused language where I actually have proper tests and things to prop it up and support it. So like I say, thanks for checking it out, and talk to you again. Bye.